I'm Shalini V, working as assistant professor. In this video, I will discuss the topic for the session 26 for first year BSc for the chapter rigid bodies. The topic of the session 26 is statement and proof for the parallel axis theorem. So before going to state the theorem, we have to know what is the moment of inertia and radius of gyration. In previous video only I explained in detail the moment of inertia and also the radius of gyration. Here I will give a briefly the what is the moment of inertia and also what is radius of gyration. So if we consider a rigid body which is having a mass capital M and its mass entire mass if it is assumed to be concentrated at the center of mass, that is C, then moment of inertia of the body which is rotating about this axis is given by I is equal to mk square, where capital M is the total mass of the body and k is called as the radius of gyration. Then what is radius of gyration? Means it is the distance of the that is the point where the entire mass is assumed to be concentrated from the axis of rotation. This radius of gyration is measured in meter. Knowing this one, next we shall consider the theorem on moment of inertia. So in the previous video, I explained the perpendicular axis theorem. Now we shall consider the parallel axis theorem. So the statement for the parallel axis theorem is the moment of inertia of a body about any axis is equal to the sum of the moment of inertia of the body about the parallel axis through the center of gravity and the product of its mass and the square of the distance between the two axes. That is, it is given by I is equal to Ig plus mr square. So where I is the moment of inertia of the body about any axis and Ig is the, in this equation, Ig is the moment of inertia of the body about an axis which passes through the center of gravity, and m is the capital M represents the total mass of the body and R is the separation between the two parallel axes. Now we shall prove the theorem. So to prove that one, now consider a rigid body. So let this be a rigid body having a mass M. Capital M is the mass of the body. Let G be the center of gravity of the body, which is situated here at G, and let CD be an axis which passes through the center of gravity. Now consider another axis AB which passes through the point O, and this axis is parallel to the axis CD which passes through the center of gravity. And let I be the moment of inertia of the body about an axis AB. So here I represent the moment of inertia of the body about an axis AB. And let R be the separation between the two parallel axes. So the distance between the two parallel axes be R, small r. Now consider a particle P which is at a distance of x from the axis CD. Then the total distance of this particle from the axis AB it is r plus x. Now let us determine the moment of inertia of this particle P about an axis AB. Let small m be the mass of this particle. Then moment of inertia of this particle P having a mass m about an axis AB, it is equal to nothing but the mass of this particle multiplied by the square of the distance of this particle from the axis AB. Then the moment of inertia of this particle about AB is given by, I have represented that one I dash AB. I dash AB is nothing but the moment of inertia of the particle P about an axis AB, which is equal to mass multiplied by distance square. So mass multiplied by distance square. Now same the figure, the previous figure only I have represented in this slide also. So now the moment of inertia of the body about AB is nothing but equal to, so for a single particle I have written in the earlier previous slide, that is moment of inertia of the particle P about an axis AB, which is equal to mass multiplied by r plus x whole square. For the entire body, if you want to write the moment of inertia, we have to take the sigma. That means we have to sum up all the moment of inertia for all the particles above the axis AB. Then total moment of inertia for the entire body is equal to sigma m into r plus x whole square. Take this as equation 2. Now expand this one by using a plus b whole square formula. Then this is equal to sigma into m r square plus x square plus 2rx. Now remove the bracket, that is sigma m r square plus sigma mx square plus sigma m into 2rx. So in this equation, if we have to take the sigma for mr square, means since r separation between the two parallel axes is same, it does not change here. So we have to take sigma only for the masses of the particles, and here also the r is constant in this one. So hence what we can write is, so take the r square outside, then sigma m is nothing but equal to the capital M, that is the total mass of the body, plus m into sigma mx square plus, since 2r is a constant, 2r into sigma mx. So in this equation, observe the second term. It is sigma mx square. Suppose if we write only small m into x square, it is the moment of inertia of the single particle P about the axis CD. But sigma mx square means the sum of the moment of inertia for all the particles about the axis CD. So that means CD is the axis which passes through the center of gravity. Hence, I will represent sigma mx square with Ig, that is where Ig is sigma mx square, which is the moment of inertia of the body about an axis CD, and this axis CD which passes through the center of gravity. Just I means it is the moment of inertia of the whole body about AB. Ig means moment of inertia of the body about an axis which passes through the center of gravity. Now, in this equation again, what does the sigma mx represents? So so this is the equation from the previous slide. So in this equation, sigma mx is nothing but the algebraic sum of the moments. Mx is nothing but, if you take the just the mass and the distance, it is the moment of a single particle. Sigma mx means it is algebraic sum of the moments for all the particles. Hence, in this equation, sigma mx is nothing but the algebraic sum of the moments of the different particles about the axis CD. But here the axis passes through the center of gravity, and about that center of gravity only the body balances. Hence, the algebraic sum of the moment is equal to 0. That is, according to the equilibrium condition, the algebraic sum of the moments must be equal to 0, and this sigma mx is equal to 0. Then substituting all the conditions, what we will get is equation 3 reduces to I is equal to mr square, but sigma mx square is equal to Ig plus this is equal to 0. The last term will get equal to 0. So finally what we will write is I is equal to Ig plus mr square, where in this equation I is the moment of inertia of the rigid body about any axis is equal to the Ig means moment of inertia of the body about an axis passing through the center of gravity plus product of, so product of the mass of the body and the square of the distance between the two parallel axes. This is the proof for the theorem. So finally, what is the statement for the parallel axis theorem? Means the moment of inertia of the rigid body about any axis is equal to sum of the moment of inertia of the body about an axis passing through the center of gravity and the product of the mass of the body and the square of the distance between the two parallel axes. So this is the statement and proof for the theorem. So I have collected this material from the books Properties of Matter by D.S. Mathur, Unified Physics Volume 1 by Dr. S.L. Gupta and Sanjeev Gupta, and Mechanics by D.S. Mathur. Thank you.